All right, good morning, class. I am looking to go through a little bit with you on item number 5 and 6 on the refrigeration modules 5 outline. And specifically what we're going to take a look at is how to use the pressure temperature charts to determine saturation temperatures and pressures for the different refrigerants. And specifically, we'll start out with item number A. So in item number A, what we have is, with item number A, is we've got what is considered as R718. And R718, as we remember from early on in the module, R718 was the refrigerant nomenclature for water. And of course, most of us won't have to look very far to recognize what is the boiling point of water at 0 psi, and most of us would recognize that the boiling point of water would end up being 212 degrees. Okay. 212 degrees. And that is pretty straightforward. Now let's take a look at R507. So we'll do the one to the right of that. Now R507, what we're going to need to do is take a look at the pressure. So just like when we were doing water in our previous modules, we need to take a look at the pressure. The pressure is going to dictate the saturation temperature. Now in this particular case, what we'll do is we'll take a look at R507. That'll identify the compound, the substance, 240 psi. So what we're going to do is look at the handout that was handed out to, which is going to be number 34. So R507 at 240 psi. So on the way these charts are structured, it's different for different refrigerants. So for example, up on the very top of this particular, on the far left side, I guess we'll go this route. On the far left side, you'll notice that they identify PSI. So everything down here represents a pressure. All of the substances that are up on the very top, for example, MP39, which is also 401A. HP62 is 404A. So what happens with these refrigerants is you'll get a manufacturer such as, it may be DuPont, or it could be Chemwars, or it could be some other company that makes a specific refrigerant. They will kind of brand it by giving it this other number other than the ASHRAE designation of R401A as an example. And so what they will do is they'll call it MP39, and that's how they'll brand that to kind of separate them from the industry, I guess, or from other competitors to their substances. So that's primarily what they end up doing. So the one that we were looking for in this module happened to be, in this case, was R507. So what I need to do is find out what R507 happens to be, and it's none of those that are in the top. And the one that we show here is actually AZ50, which is also 507, R507. Now every number, again, that we talked about, every number on the left side, this is all going to be in pressure, is the way this is going to be. Now these, the ones that are in the asterisks, you're going to notice are identified, should be inches of mercury vacuum. So if you'll notice on this particular chart, the inches of mercury, that asterisk means inches of mercury below atmosphere. So that's how they're setting that up. So let's just think of that as everything that's all in these are all going to be inches of mercury vacuum. Normally, we do not want refrigerants operating in those vacuum areas if we can help it. We can't always, but that's what we would like to do. So for example, if I had 0 psi that's right there, that would be 0 psi G. And if it were refrigerant 11 or refrigerant 12, excuse me, that refrigerant 12 would have a boiling point or a saturation temperature of, in this case, minus 22 degrees Fahrenheit is the way that that would work. And that's primarily how we would do that. So let's go ahead and find 507 per the module. And what we're going to do is try to find 240 psi. So in this example, I have 240 psi, and I need to go all the way over to the 507. Now 507 happens to be in this particular row, the second one in from the right side at 99 degrees. So I'll just go and verify, and of course that is indeed the case. Now, so back to the module, and what we're going to do is list that in here is 507 should end up being, oh, where's my little chart here? Whoops. And set that up, and that's 99 degrees Fahrenheit. Okay? All right. So let's take a look at R22 as the next one. So R22, and again, I'm going to go back to my chart. So I have 0 psi. So I'm really looking for what is the saturation temperature of R22 at 0 psi. So in this example, I'll highlight that one. R22 happens to be minus 41. So I'll go back to the module, and that will end up being minus 41. So this new little app that we have here, whoops. Let's try this again. Maybe. All right, so let's type that in. Negative 41, whoops, 41 degrees Fahrenheit. Got it. Okay. And we're going to move that into place, minus 41 degrees. So that's minus 41 degrees Fahrenheit is the boiling point. R404A, that's another one. So we're going to look at that one also at 0 psi. Now, R404A, let's look at the Sporlan chart, 404A, and you'll notice that it is not in any of these. And we'll go to up here, which of course 404A happens to be one of those little blends that isn't necessarily a pure substance. We'll be talking about that additionally. And again at 0 for the 404, I'll type 0 there, 404A, and that is of course minus 50. Now going back to the module, in this case, we'll type that in, and this will end up being, alright, so negative 50. Minus 50 degrees Fahrenheit. All right. Okay. All right, let's look at R410A. And R410A happens to be at 120 psi. So when we put a pressure, or when R22 is pressurized at 120 psi, what will be its boiling point, or what will be its evaporating temp, or its condensing temp? And so in this case, R410A, 120 psi, and on this particular one here, you'll notice that it's not in any of the top ones. So let's go down to the next one, and this 410A, you'll notice doesn't appear to be on this chart. Now let's take a look in the top in case that was the case. So they have 409A, they have 408A, and several others. So this is one of the things that will happen occasionally, where you'll have a pressure temperature chart that is maybe supplied by a manufacturer that maybe these particular charts are used for certain applications such as more in the refrigeration industry where R410A really isn't used for that. So let's take a look at a different handout. So in your handouts, I'm going to pull up handout number 33. And handout number 33 will indeed have that. So handout 33, what we're going to do is take a look at handout 33, which is the Elko PT chart. Now I have several handouts in here that we can take a look at. So specifically, I had said 120 psi and what was the saturation temp. So this is probably a good one to do. Now what we're going to be looking at is specifically R410A, which is going to be, let me see if I can get that to show up. Nope. So R410A, and what we're going to do is we're going to take a look at R410A on the far right side. Now what we're going to notice on here is they're going to go, they give me at 120 psi, and in fact this chart specifically is showing 120.5 psi. So it's a little bit less than, it's a little bit less pressure than the 120 psi that was identified. So let me see if I can circle that. So in this case here, we've got R410A, 120 psi, so right there. And of course, that would tell me that the saturation temperature would be probably the closest to 40 degrees Fahrenheit, in my opinion. Now, based on looking at that chart, so that would be one. Now, what I want to do, and I'm going to mark that down as 40 degrees, and we'll go back to the module, and then I'm gonna double check something. So. Alright, so we're going to put that as 40 degrees Fahrenheit. Now, what I want to do though is just to show you, and in real life, we probably would say that that's adequate or that's appropriate or normal. So what I want to do is take a look at handout number 36. And we're going to pop that one open and see that. Now 36 is going to give us maybe a little bit different glimpse of it. And so what 36 is going to be, and you'll notice that on handout 36, that happens to be the temperature pressure chart that is from Fluke. And 410A, you'll notice, happens to have on this right side, the far right side, 410A, and it's also called AZ20. So the manufacturer of this 410A has given it kind of a trade name of AZ20. Some people, you know, like some of the manufacturers you might have heard of before, like Carrier or O'Brien, they might have used the term Puron as an example, and those are typical of the way that this industry kind of goes. So let's take a look at 120 psi on the far right side, and the far left side will be the temperatures. So in this example, you'll notice there's a slight difference or a slight discrepancy from one chart to another. Now on this particular one, you'll notice I'm at, on this particular one, here, let me go back up to here. So on this particular one, you will notice that 120 psi and 410A would be almost in the middle between these two temps. So if I were using this particular chart, I would likely be calling that 41 degrees instead of 40. And you're going to notice that even on some of the applications that you guys might be using or might use on your particular phone even, or on the iPads. And so I'm going to list this as 41 degrees Fahrenheit as a possibility. So it really depends on what chart you use. So if you're off by sometimes, let's say, a degree or so, it's fairly minimal in most cases, in most applications, simply because we don't try to be that tight on a lot of these. So let's take a look at the next one. So R134A at 0. So let me go back to I'll go back to the standard Sporlan, and R134A at 0, and 134A, let's see, it's not on this one, and 134A, maybe it's on the next one. and of course it's the one they're listing in that is identified as blue. Okay, right up here, and 134A, you'll notice that one is at 0, is listed as minus 15. So I'm going to go back to my module, and I will go ahead and put that in there. So in this case, minus 15. Oops. Let's try it this way. Negative 15. Okay. Oops. All right, that one didn't work. Let's try that again. All right. Negative 15. Okay, got it. And minus 15, we'll leave that there. And just for the sake of discussion, I'll look at a different one of these. And of course, 134A on this particular flute chart happens to be right there. And of course, at 0, now you'll notice that they list their temps on the left side. And in this particular case, the temps on the left side would be right in the middle of these two right here. And of course, I would just call that minus 15, and we would interpret that. So that's good. That's simply how you do that. All right, let's go back to the module. So the only difference between number 5 and number 6 is one of them we're giving you the pressures, and the other one, and we're looking, or one of them we're looking for, we give you the pressures, that's number 5, and we're looking for the saturation temps. On item number 6, we're giving you the temperatures, and we're saying what's going to be the expected pressure, and that would be really the difference. So it's just it kind of changes the approach a little bit. Now there are many apps that we use in our industry that will allow us to do this and to type in the pressure that I get or the temperature that I get, and tell me what that pressure would be, what the saturation temp is. And again, I want to reiterate, these are all like saturation temperatures of all of these systems. So let's go back to the spoiler handle. So the first one we'll look at is, and sometimes what I tend to do is I tend to use applications that are easier to use. So for example, or temperature pressure charts that are easy to use. So for example, 105 degrees, if I go 105 degrees and I say, all right, I have R22 at 105 degrees, you'll notice some of the charts may not necessarily be a good fit to use. So R22, 105 degrees. Now you'll notice that on this particular row or column, we are going to have R22 listed at 210 psi for the 105 degree saturation temperature. And I'll go back up to here and I'll point that out again. That is the green setup that is identified here. So what they're listing is green and R22, and that's how we're going to do that. So I think I feel comfortable enough at this point on this one that I'm going to list this at R22, and we're going to list that at 210 psi. So R507 at minus 20. So R507 at minus 20. So R507, another one of those refrigerants you might remember from up above, we listed that as R507. Here we're going to look at it minus 20. I'll go back to the Sporlan chart. And again, 507 minus 20, that's also AZ50. And in this case, we have minus negative 20 degrees. Now this chart lists it as minus 20. And of course, on this particular manufacturer, using the Sporlan chart, it's pretty evident that at minus 20, they are listing this at 18, in this case 18 psi. Now you may find other charts. So for example, let's look at the the Elko chart, and we'll find on the Elko chart. So we'll see if this is listed on here. So we wanted our 507 and 507. There we have it. And here you'll notice that they have a different number here. So they are listing this one. You'll notice our 507 is right there. They're also going to notice that we were given negative 20 degrees. Now, in this particular case here, minus 20 degrees Fahrenheit, you'll notice here this one is listing it as 17.8 psi. If I go to the flute chart, 17.8, so 507, let's see if that's listed on this particular one here. 407, 507, and I do not see 507 listed on this particular chart. So they evidently haven't done that. So I think, considering what we had on the Sporlan chart, I think we have the minus 20. We list the pressure in there at 18 psi would be adequate. So I have other applications that will actually have our 507 at minus 20 listed at 17.5 psi. So I'll go with the 18 psi that we had identified. So again, minus 20 psi or minus 20 degrees Fahrenheit, and 18 psi is sufficient, so close enough. 410A at 95 degrees. So in this particular chart, we're going to list our 410A at 95 degrees. So let's see if we can find that one. So 410A, so we'll start out with we can look at the flute chart in this case. So the flute chart, so again, we had our 410A, that was on the far right side. We are going to use 95 degrees Fahrenheit. So let's go all the way up to the 95. And again, we're staying on the far right side. Make sure that that they don't switch. Now you'll notice here they don't really list 95. What they do is they're listing something, and they give you 94, they give you 96. So you're going to kind of split the middle here to some extent. Here you'll notice it's between 290, let's call it 291 and 299.4. So I would say, if we were to split the middle between those two, that's probably going to be right in that ballpark of somewhere in that 295, 296 range. If I look at the Elko chart on here, 410A is on this particular one here. And let's see if they list 95. So here they do something very similar, and you'll notice the temperatures are actually different as well. So 94, 95 degrees, if we go right in the middle of these two, 294 to 302, again, numbers will vary slightly. I think we could safely identify that in this particular one as 295 psi. Oops. Okay. Oops, that didn't work. Okay. Let's try that again. Let's try listening. 295 psi. All right. The last one on this particular module that we'll be looking at in here is R134A at 17 degrees Fahrenheit. So again, we'll go back to the Sporlan chart, and we wanted to know, of course, 17 degrees. We'll see if that's listed. I guess whenever possible, you try to find one that identifies it. This particular chart has it as 134A, 17 degrees, so we're going to be looking in here. Now you'll notice it should be right in the middle of these two, so 17 degrees. So it's kind of interesting the fact that we're going to be somewhere in that 16.5 psi is the way I would identify that. So on my chart, I can list that very safely at .5 psi. Okay, and I'll pop that into place, and there we go. All right, so that concludes how to utilize the temperature pressure charts to find out where your saturation, either saturation pressure is, or to find out where the saturation temperature will be, depending on whether you're looking for pressure or temperature.